Alright, I guess we're recording now. Alright, our objectives today, this is the third time I've done this, by the way. I know you guys don't see all these versions, but this is the last time I'm doing it. Hopefully it works this time. Our objectives: summarize the theory of plate tectonics. Remember, we're talking about the advancement of the theories from continental drift to seafloor spreading, now to the plate tectonics theory. We're going to identify the three types of plate boundaries that are formed, and then we're going to list and describe three causes of plate movements that happen. And this is the whole idea here, is why our plates are moving. Plate tectonics theory explains how large pieces of the lithosphere, which are plates, move and change shape throughout history. These lithospheres, solid outer layer of the Earth, and it includes the crust and the upper part of the mantle. Now, we've talked about the Earth being broken down in parts before, the crust, the mantle, the core. Well, in this case, we're going to take the upper part of the mantle and the crust to make the lithosphere, and that's where these plates are located. The other part right below that is the astenosphere, and that's a plastic layer. And that's important because it kind of flows real slow, but because of that flowing, that's what allows these plates to move on top of it. Here's a picture that helps. Lithosphere forms a tiny outer shell of the Earth, broken into several blocks of plates. The tectonic plates ride in the astenosphere. They use the example like blocks of wood on water. I don't quite buy that. It's a little different than this, but that idea works. The tectonic plates can include continental crust, oceanic crust, or both. So these plates, we can get parts, and I'll show you that in a minute. And they're carried along the plate the same way they use the example passengers on a bus. I don't really like that one either. Let's talk about the fact that since it moves, anything that moves underneath it is going to carry it along. Okay? So, I guess passengers on a bus. There are about 15 major tectonic plates. There's some smaller ones in there. The way we find these is by earthquakes. When an earthquake happens, we map where it is. When we get a bunch of earthquakes, we see that these distinct lines form around the Earth, and we know that's where the boundaries are. We can't see the boundaries in most places, so we don't know exactly where they are. The earthquakes help identify. We can also use volcanoes, especially along the west coast of the United States and around the Pacific, the Ring of Fire, because those volcanoes help identify where that Pacific plate is. Here's a great picture of the different plates that happen. The Pacific plate's in the middle there, North American plate. You see the different plates and the boundaries that happen. We found earthquakes that happen all along those lines, and that's where we decided those plates were. Now, how do scientists identify locations of plate boundaries? I've told you that a million times already. Pause your video, write it down, then come back to me. Thank you for pausing. Okay? You should have wrote down the main one is earthquakes. But there are some others: volcanoes, trenches, and mid-oceanic ridges. Earthquakes are the main one, though. Make sure you keep that in mind. Alright, now, these boundaries we talk about, they can be in the middle of the ocean, they can be on the edges of the ocean, they can be in the middle of a continent. Along the coast of Africa, or in the continent of Africa, one of the best movies ever made, The Lion King, was formed in a rift valley, basically, where the continent itself is breaking in half. That's where Lion King was supposedly set. There's three types of boundaries. The first is a divergent boundary, there's a convergent boundary, and a transform fault, or transform boundary. Now, we're going to make some hand motions with these. So as we go along, bear with me. Okay? Each plate, you get some type of geologic activity that goes with it, and we'll talk about that as we go along. But here's the divergent boundary. So your hand motion. Divergent means it goes apart. Your model does that. So remember, this is your, everybody put your hands together. Divergent, pull apart. And that's what's happening in the video up here. Your model, you pulled the strips of paper, it pulled those plates apart, and gave you your mid-oceanic ridge. Okay? Remember, magma does not push them apart. They pull apart, magma fills the hole, just like your paper does. Next one's a convergent boundary. That means they come together, converge, come together. Now in this case, this picture shows a subduction zone. Subduction means that this plate, I think it's probably opposite because I'm looking at the camera, but the plate on the underwater there is denser. Because it's more dense, it's forced under the other plate. As it's forced under the other plate, this lighter, less dense plate floats up on top. This one's forced down as it is. It melts as it gets warmer, and that magma that melts wells up and works its way up to the surface and forms volcanoes. That's what's happening all along the Pacific. The Pacific is getting smaller. The Pacific plate is being overrun by the continental plates, and as those Pacific plate, which is denser and thicker, denser, gets forced underneath, it melts, and we get those volcanoes that form all around the Ring of Fire. Last hand motion, transform fault. Hands like this. This one slides up. Okay? Now, transform fault, the most active fault in the world is the San Andreas Fault. The San Andreas Fault is in California. And that video, as you can see in the picture there where that river is, there's been so much movement that rivers have changed course. So the rivers used to come together here, now all of a sudden they're here. Roads that used to come together here, now all of a sudden they're like this, and you have to make an S-turn. So you have all those various things that happen. One of the biggest things is when we talk about land usage, that if you own this land here and you put a fence up, all of a sudden an earthquake happens, you shift, and now your land, where does it start? Does it start back here where your old fence is? Start up here where you're cutting into somebody else's land? It's been some real major court cases in California that have caused some major problems. Why do the plates move? There's three types of heat transfer. There's radiation through space, sun's rays to the earth. There is conduction, where if you're stirring your soup with a metal spoon and the soup gets hot, as it does, that heat transfers up the spoon into your hand. Same with like holding a metal bar and using a torch on it. You're heating it up over here, that heat transfers right down the bar and burns your hand. That's conduction. Then finally, convection. Convection is based on the movement of fluids. Fluid or anything that flows. Air, water, soup, magma. I go down the list, you get the idea. In this case, we're talking about magma. As magma is near the core of the earth, it heats up. As it heats up, it becomes less dense, starts to rise, gets up here. As it gets up here, it cools down. And when it cools down, it becomes more dense, sinks, and does the cycle again. It forms a circle. Okay? That circle is, as it heats up, becomes less dense, cools down, becomes more dense, is called a convection cell. And we're going to talk about that in this slide right here. So that process, and you can see that they use the example of water boiling in a pot, and it does. It wells up in the middle, circles out to the outside, cools off, and sinks back down. That convection cell becomes very important because that transfers a lot of heat throughout a convection current. Now, scientists think that magma itself is a convection, that magma follows a convection cell. And as it spins around, it heats up by the mantle, rises, becomes less dense, rises, comes around, it cools off, becomes more dense, and sinks. As it sinks down, as it does this circle here, it drags anything along with it. So that would be just like if you took a pencil, paper, and you laid the pencil on your desk, laid the paper on top of it, and then turn the pencil. Your paper is going to move because the pencil beneath it is moving. That's something that you can try right now. Take a pencil, take a paper, lay the pencil down, lay the paper down, and roll your pencil. It's not going to move it completely, but it's going to slide a little bit, and that's what happens to our plates. As those convection cells move, the plates move along with it. Alright, here's some other ways the plates move. You get a ridge push. You have a moving asthenosphere that is moving because the lithosphere is pushing down into it, and it causes the plate to slide with it. Okay, this is caused by gravity pulling on that lithosphere. Second way is a slab pull. The denser material is being pulled down due to density, so it's sinking. As it sinks, it allows this other plate to slide right on down, and that's called a slab pull. Okay? Hopefully this is the third time, hopefully this is the right one. I've done it 3 times, and hopefully this time came across right. I hope you enjoyed it. There is another video at the end. I will watch it another time. Remind me to put it up in class. Thank you.